Hello, discrete math students. I'm using a new software to create this video, so I'm going to keep this video short because I want to make sure that this software works properly. So I'm looking at this problem in your homework. This is my problem 3. It could be a different problem for you. My problem 3 could be your problem 20. Your problem 20 could be my problem 10. My problem 10 could be your problem 70. The ordering is going to be different for everybody, I believe. And sometimes even the numbers will be a little bit different from student to student. Okay, so let's do this example. Hopefully you can see it okay. Let me make this just a little bit bigger. Okay. I'm also going to start Wolfram Mathematica. So let me see. I'm going to go into my applications folder. And where is Mathematica? Mathematica is right here. Okay. I'm just waiting for that to start. Okay, click on New Document. And let me see. Okay, so, well, first, okay, hold on one second. Let me format this Mathematica notebook so that it looks a little bit nicer. Edit, so format, edit style sheet, input, and output. Click on input. Click on format. Show fonts. I'm going to choose font size 18, and I'm going to choose Arial. And the color, how about dark blue or midnight? Okay, and we can do the same thing with output. Font size 18, we're going to make it bold. And I like Arial. Choose whatever font you prefer. And let's see, how about dark blue? Okay, so I think we're ready to go, and then just close the window. Let's see if it works. So print welcome to discrete math. Okay, I don't like the styling very much. We can style that a little bit better, can't we? So we could style that, style, and font family is Arial. Font size is 18. Font color is, oh, how about red, green, blue color? We could do a little bit of red, half red, no green, and some blue. It's going to look purple. And then font weight could be bold. Okay, we could make that even a little bigger. We could do 22. And let's make this even more interesting. How about we repeat this 10 times? For k is equal to 1. K, pick a variable name. I'm choosing k. Use whatever variable name you want to use. K is less than or equal to 10. And for this one, let me see. We're going to do toString k. And we'll do a string concatenation. And let me see here. And k plus plus. Okay, so we have 1, welcome to discrete math, and 2, and 3, and 4, and 5. So this is repetition, right? And we could actually put in a pause this maybe for 2/10 of a second, and shift enter. Okay, so this is your classic for loop. So 1, welcome to discrete math, and 2, welcome to discrete math, and 3, and 4, and 5, and 6, and so on and so forth, okay? So if you don't quite understand this right now, don't worry about it. I will probably save this and email this document to you, and you can work with it and practice and experiment with it and make changes, whatever. Okay, so let's get serious about your homework. So here we see the problem says for the sequence an, here let me make this a little bigger. For the sequence an is equal to -2 an minus 1 and a0 is equal to -1. The values of the first 6 terms are, and of course they're showing me the answers because this is the teacher's version of the software. Okay, let's see if we can figure it out for ourselves without looking at the answers. All right. So I see that the recurrence relation is an. So each term of the sequence A is equal to -2 times the previous term. The first term, A0, is equal to -1, and we're looking for the first 6 terms of the sequence. Okay? So let's see if we can define that. Let's say A of n is equal to 2 times A of n minus 1, where A of 0 is equal to, I believe it was -1. Okay, I believe that's correct. So this is called a recursive definition, and by the way, you do need the underscore right here, because this is telling Mathematica that n is an argument to the function, but you don't use it on the right side. This is called delayed evaluation. It's probably not a big deal for this problem. For more complicated problems, you really should define your functions using colon equals. Equals will probably work just as well, but in general for your functions, you really should use colon equals. The first value of the sequence is -1. Okay, shift enter. If we don't want to see the -1 as an output, just put colon after -1. Okay, shift enter. So let's see, table an, n goes from 0 to 5, and that will give us the first, oh, I'm sorry, I should have, this is -2. -2. Okay, so table an, where n ranges over the integers from 0 to 5, will give us the first 6 values of the sequence. Okay, output the first six values of the sequence that we call A. Okay, let's table form it so that it looks a little bit nicer. 0 to 5, table form. Okay, there we go. So we have Let me see if I can make this a little bit smaller. Okay, so we have the values negative a0 is -1, a1 is 2, a sub 2 is -4, a3 is 8, and oh wait 1 second, and then we have this. Okay, this window really got squished, and the next term is -16, a4 is -16, and finally a5 is 32. Simple. Okay, so let's do a couple more. Let me see. Okay, this problem, one moment. The recurrence relation a sub n is equal to negative a n minus 1 with the initial condition a0 is equal to 5. And now what exactly are they asking for here? I think they're asking for a closed form solution. Oh, they're asking for a closed form solution of this. I'm not sure I want to get into this in this particular video. Actually, Mathematica does have a tool that you can use to solve this. Right now, I don't want to get into this problem in this video. I want to keep this video reasonably simple. Let me see. Okay, I'm looking at some other problems here. These are basically plug and chug problems, and they should be pretty easy for you to do. Yeah, most of these problems should be pretty easy for you to do. For example, okay, what is being asked in this problem? So this is my problem 16. A1 is equal to, so plug n is equal to 1 into the formula. An is equal to 2 times -3 to the power n plus 5 to the power n. Oh, this is just a substitution problem, which is pretty simple to do. So here they're asking you if n is equal to 1, what is the value of this expression? That's pretty simple to do. So let me resize this window a little bit and go right over here. Let me resize this window a little bit so that you can see this. All right, 1 second. So the expression that they're showing you in this problem is 2 times -3 to the power n plus 5 to the power n, and we're going to do a substitution. N is going to be replaced with 1. Shift Enter. If we replace n with 1, then this entire expression here is going to be -1. I could also do this. N is equal to 1. Sorry. 2 times -3 to the power n plus 5 to the power n is -1. However, now I have to worry about the value of the variable n. So I could always clear that, clear n, and now I could give n a new value. I could give n a new assignment. Personally, I would prefer to do it like this. I think this is actually a better way to do the problem. 2 times -3 to the power n plus 5 to the power n. N is 1, and the answer is -1, which we see is the answer right over here. Okay? All right, guys, I think that's going to be it for now. I don't want this video to get too long because I'm experimenting with new software here, and hopefully I'm not wasting my time here. Hopefully this video will be good enough to upload to YouTube and good enough for you to watch and learn from. Okay? And let me see here. I'm going to